Okay, let's take a look if we are live. Okay, should be good. Hello everyone. So first of all, let's take a look what we read last time. We start chapter 7, managing growing project with packages, crates and modules. So we read first 3 sections, packages and crates. So we found out there is a binary crate and also library crate. And I think this was main point here. There is some rules regarding the modules, how the modules work. So start from create root. Basically, if we have absolute path to the something in the module or submodule, it starts with the root create module, declaring module. Yeah, we can have module, and these modules can have some modules, and this is like a tree. This is path to asparagus inside a root module create. Then we define a garden module inside it, in submodule vegetables, and inside we created, I guess it structs asparagus. Use keyword, I think we haven't read about it. We will do it in section 7.4. So yeah, this is structure of in main RC. We can define module garden, then we can have garden RC with its definition, and we also can have submodules in the folder garden. So each module can have several submodules and etc. So, and the 7.3 is about the passes. Basically, there is absolute path and relative path. Absolute starts from the root crate and relative from the place where we currently starting. For example, this is absolute start from crate, but now we already in lib.rc, so we can skip this part. If you're somewhere in the front of the house, we can skip the front of the house and start from the house hosting, add to waitlist, something like this. Yeah, discover a bit of encapsulation a bit, so everything is private. It can be accessible from the top, and to make it accessible we need to make it pub. And from for enums, it's public for by default. So yeah, basically something like this. We refresh a bit in memory what we were at last time, and maybe let's jump into the section 7.4. And this is about bringing paths into scope with the use keyword. So the use keyword we saw previously, finally we can find out about it more. So having to write out the paths to call functions can feel inconvenient and repetitive. In listing 7.7, whether we choose the absolute or relative path to the add to waitlist function, every time we wanted to call add to waitlist, we had to specify front of house and hosting too. Fortunately, there is a way to simplify this process. We can create a shortcut to a path with the use keyword once, and they use the shorter name everywhere else in the scope. Okay. Yeah, basically it will be really annoying to have full path or even a relative path to the function or something we want to bring from the modules. So this is kind of common practice in different languages. We have something like import or include, etc., where we can import or include different libraries or different files. In listing 7.11, we bring the create front of house hosting module into the scope of the eat at restaurant function. So we only have to specify hosting add to waitlist to call the add to waitlist function in eat at restaurant. And here we are. Use create front of house hosting. And now what we can do start from the hosting. I guess we have some code here, not this one. There is not much code here, but I guess we had other example last time. It's probably backyard. So let's, yeah, there is some modules, the asparagus, and actually we already used here use, but for example, if we don't import the asparagus directly but only vegetables, and if we save, the compiler analyzer will complain about it, but if we use it like this, vegetables asparagus, then it's fine. Okay. Adding use and a path in a scope is similar to creating a symbolic link in the file system. By adding use create front of house hosting in the create root, hosting is now a valid name in the scope, just as the hosting module had been defined in the create root. Paths brought into scope with use also check privacy like any other paths. So basically, yeah, with use in C++, I remember there is using namespace like this, so I can bring some module like it's defined right here. So note that use only creates the shortcut for the particular scope in which the use occurs. Listing 712 moved the eat at restaurant function into new child model named customer, which is then a different scope than the use statement. So the function body won't compile. Let's take a look at this one. So this is actually interesting. So we have use hosting here, but we cannot use it here because it this is actually interesting. Do we have maybe so backyard and restaurant? Okay. I might be haven't saved the project with other examples. But anyway, we can try to do something similar here. So we use create, then we can create mod, I don't know. For example, yard. And we can define some pub, whatever. I'm a pub function play. So now print what we see here. We cannot use vegetables from this use because it is in different scope, but if we bring it here, cargo build, yeah, there is no problem. But if we comment it out and run cargo build, use of undeclared crate or module vegetables. Okay, so for example, with modules we can access the things from the upper scope, but for use keyword it works only for the scope inside which we use it. So no upper or inner have access to it. It's more or less clear. Let's continue. The compiler error shows that the shortcut no longer applies within the customer module. Yeah. same as we have. Notice there is also a warning that the use is no longer used in its scope. Maybe if we so unused import, yeah. To fix this problem, move the use within the customer module too, or reference the shortcut in the parent module with super hosting within the child customer module. Oh, this is interesting. Something we also can use super. Something from the parent scope. Okay. Creating idiomatic use passes. So in listing 711, you might have wondered why we specified use create front of house hosting and then called hosting at waitlist in it at restaurant, rather than specifying the use pass all the way out to the end at the waitlist function to achieve the same result as in listing 713. Okay. Also, both listing 711 and 713 accomplish the same task. Listing 711 is the idiomatic way to bring a function into the scope with use. So 711 is the idiomatic way. Okay. Bringing the function parent module into scope with use means we have to specify the parent module when calling the function. Specifying the parent module when calling the function make it clear that the function isn't locally defined while still minimizing repetition of the full path. The code in listing 713 is unclear as to where add to waitlist is defined. So yeah, I think good point to make it more clear. There is some hosting module and we using it function, and if we would like to understand where it comes from, so we will look to the hosting module, and in case we have just add to waitlist function, it feels like it defined it somewhere next to our code, and you may be surprised that it comes from the other place. Not super big deal, but yeah, just this idiomatic way, as it's called in this title. I think it makes sense. On the other hand, when we bring in instructs, enum, and other items with use, it's idiomatic to specify the full path. Show the idiomatic way to bring the standard library hash map struct into the scope of binary crate. Yeah, hash map is like from the standard library, and everyone who is like not super new to the Rust will recognize this is from the standard library collections hash map, and you can just use it, and you never like confused where it comes from because you're familiar with this So there is no strong reason behind this idiom. It's just the convention that has emerged, and folks have gotten used to reading and writing Rust code in this way. The exception to this idiom is if we bring in two items with the same name into the scope with use statement, because Rust doesn't allow that. Listing 7.15 shows how to bring two result types into scope that have the same name but different parent module and how to refer to them. So I guess we have result in FMT module and also in IO module. And in this case, don't bring result, but we stop on the upper level, and it's also clear what we are doing here. As you can see, the parent module distinguishes the two result types. If instead we specified use std fmt result and use std io result, we'd have two result types in the same scope, and Rust wouldn't know which one we meant when we used result. So yeah, no, this is basically clear, but as it says, it's not something like a strong rule or something. You can do it whatever you like, but there is common practices in the community, how the people use it, and they basically comes from the way it makes sense to do it like this. Providing the new names with the S keyword. There is another solution to the problem of bringing two types of the same name into the same scope with use after the pass. We can specify S and the new local name or alias for the type. Listing 7.16 shows another way to write the code in listing 7.15 by renaming one of the two result types using S. So yeah, we have similar thing in the JavaScript, TypeScript. We can import and say name it differently, something similar. I think with S as well, or yeah. Okay. In the second use statement, we choose the new name IO result for the std IO result type, which won't conflict with the result from std fmt. This we also brought into scope. Sorry. Listing 7.15 and listing 7.16 are considered idiomatic, so the choice is up to you. So yeah, this is two alternatives. We can put new name this S keyword and create a clear name in here, or we can just use upper scope, upper piece of the pass, so it's also, I don't know, exactly in this example I feel like this one looks better to me. And it's like, you know, you stay with standard result, you don't bring new name in, you know, IO result, familiar with FMT result, and it's super clear what it is. Now if you see in the code IO result, it's something you expect. It might be IO result, but it actually could be anything else because it's some custom name. But yeah, completely makes sense in some cases to use as keyword, as for me at least. Re-exporting names with pub use. When we bring a name into scope with the use keyword, the name available in the new scope is private. To enable the code that calls our code to refer to the name as if it has been defined in that code scope, we can combine pub and use keywords. This technique is called re-exporting because we are bringing an item into scope but also making that item available for others to bring into their scope. Listing 717 showed the code in listing 711 with use in the root module changed to pub use. Okay, and what actually changed? Is it like, will it work if we place pub here? No. And if we do it like this, can we use yard vegetables now? Okay. So we re-export vegetables here, make it available with pub keyword in the yard module, and now we can access it not from the garden vegetables but from the yard vegetables. This is, yeah, I think it can be useful. I imagine there is a use cases you need this. So before this change, external code would have to call add to waitlist function by using the pass restaurant front of house hosting add to waitlist. So basically starting from the scope we are now with relative pass. Now this pub use has re-exported the hosting module from the root module. External code can now use the pass restaurant hosting add to waitlist instead. Okay. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in this restaurant metaphor, the people running the restaurant think about front of house and back of house, but customers visiting visiting a restaurant probably won't think about the part of the restaurant in those terms. Yeah, sorry. With pub use, we can write our code with one structure but expose a different structure. Doing so makes our library well organized for programmers working on the library and programmers calling the library. We'll look at another example of pub use and how it affects your grades documentation in the exporting convenient public API with pub use section of chapter 14. Yeah, we're on the halfway to the chapter 14. We're in chapter 7 now, but I think we finish it today. But yeah, what we just read here, like external users of your library maybe will not have the same access as you have inside the library, and you might want them access different part of your module or library, whatever, differently. You don't want to have the full path, you just maybe have some, I don't know, route where you can export some component, etc. Yeah, completely makes sense to me. Using external packages. So yeah, this is important one because we daily, as a developers, we are using external packages a lot. This is strength of the development. We can use pieces some other people wrote it for us, and we don't need each time start from scratch. In chapter 2, we programmed a guessing game project that used an external package called rand to get random numbers. To use rand in our project, we added this line to cargo toml. File name, okay, cargo rand version 085. Adding rand as dependency in cargo toml tells cargo to download the rand package and any dependencies from crates.io and make rand available to our project. Okay. Then to bring rand definition into the scope of our package, we added a use line starting with the name of the crate. Okay, so yeah, it's not start from the crate root root module crate or root package. I forget how it's named correctly. Some root module name, I guess, is crate, but this is different package, so we start with package name. And then to bear in definition scope of our package, we added a use listing in the item. Recall it's in generated random number section 2. We brought the RNG trait into scope and called the rand thread RNG function. Okay. Actually, use rand RNG, and here we use rand. We don't use the RNG here. Let me quickly look. Guessing game. So we use rand. What if we do it like this? And what? Can I do it like this? No. Can I use rent? So far I didn't completely get it. We brought RNG trade into scope and called. Okay, members of the Rust community have made many packages available at crates.io, and pulling any of them into your package involve the same steps, listing them in your package cargo toml file and using use to bring them from their crates into scope. Yeah, but I still didn't really get it, how it works. RNG is a trait. And we use thread RNG. So I can do something like this. Okay. Okay, I don't completely understand what happened here, but yeah, let's skip it for now. Maybe later I will get it. Note that the standard std library is also a crate that external to our package. Because the standard library is shipped with the Rust labels, we don't need to change cargo toml to include std, but we do need to refer to it with use. Okay, but we don't need to refer to it with use. To bring item from there into our package scope, for example, with hash map, we would use this line. Okay. This is an absolute pass, starting with std, the name of the standard library crate. Yeah, same like in C++, I guess. Using nested passes to clean up large use lists. Okay. If there If we are using multiple items defined in the same crate or same model listing each item on its own, a line can take up a lot of vertical space in our file. For example, those two use statements we had in the guessing game in listing 2 bring the items from std into scope. So basically, yeah, std cmp and std io. Instead, we can use nested paths to bring the same items from scope in one line. We do this by specifying the command part of the path followed by 2 colons and then curly brackets around a list of the parts of the passes that differ as shown in listing 718. So yeah, this is what we actually just tried. So now we can so RNG basically is inside the rand, and red RNG also in the rand, and we can put a list. But I didn't exactly get what is RNG. It's a trait, and we learn about trait later, so maybe yeah, this is not needed to dive into it right now. In bigger programs, bringing many items into scope from the same crate or model using nested passes can reduce the number of separate use statements needed by a lot. We can use a nested pass at any level in a pass, which is useful when combining 2 use statements that share a subpass. For example, listing 719 shows 2 use statements, one that brings stdio into scope and one that brings stdio right into scope. The common part of these 2 passes is stdio, and that's the complete first pass. To merge this into one use statement, we can use self in the nested pass as shown in listing 720. Okay, so self means stdio. Yeah, this line brings stdio and stdio right into scope. Exactly. The globe operator. If we want to bring all public items defined in pass into scope, we can specify that pass followed by the star globe operator. So basically bring everything from std collection. Okay, this use statement brings all public items defined in the std collections into the current scope. Be careful when using the globe operator. Globe can make it harder to tell what names are in scope and where a name used in your program was defined. The globe operator is often used when testing to bring everything under the test into the test module. We'll talk about that in the how to write test section in chapter 11, which I'm really waiting for, because I keen to learn about testing more. The globe operator is also sometimes used as part of the prelude pattern. See the standard library documentation for more information on that pattern. Other preludes. Preludes can be seen as pattern to make using multiple types more convenient. As such, you'll find other preludes in the standard library, such as stdio prelude. Various libraries in the Rust ecosystem may also define their own preludes. The difference between the prelude and these other preludes is that they are not automatically used and must be imported manually. This is still easier than importing all of their constituent components. Okay. Okay, I think we're done with this section. It's basically quite understandable. Just importing packages, library, modules with the used command, how we can use it, etc. So let's jump to the last section of the chapter 7. It's not a big one. Separating modules into different files. So far, all the examples in this chapter defined multiple modules in one file. When modules get large, you might want to move their definition to a separate file to make the code easier to navigate. Okay. For example, let's start from the code in listing 717 that had multiple restaurant modules. We'll extract module into files instead of having all the modules defined in the create root file in this case. The create root files is src librc, but this procedure also works with binary crates whose create root file is src minrs. First, we'll extract front of house module to its own file, remove the code inside the curly brackets for the front of house module, leaving only the mod front of house. Okay, declaration. So the librc contains the code shown in listing 721. Note that this won't compile until we created the src front of house rc file in listing 722. Okay, let me visible order. Yeah, generation is good, especially when you talk a lot or reading a lot. So what happened here? Like I have, I think I delete this code, so maybe let's back to it. Let's quickly look what in our enums. No, it's definitely not what we're looking for. So let's create new one. Cargo, new modules 7. Now what we need, listing 17. This is where it actually was. I think this is actually what we need. So we have model front of house, and So first we extract the front of house model to its own file and remove code inside curly brackets. So okay, front of house RC and here we can we should make it public and this one public also. Um, build. So no hosting in front of house. No, this won't compile until we create the front of house RC file. We did created it and we make it pop. What is wrong here? Front of house. Let's check if I did any mistake. We can try rename it with copy paste. I don't think anything changed, but just to be sure. Should we make this one pop? No. Front of house. Okay. This green suggestion, like no, this makes sense. So I wrap it twice, so like now it's like this. So if I do it cargo fmt, so format it for me please, and back to me, and now we can delete this piece. This is fine, so I don't need pub here as well. And now I can do hosting, add waitlist. Yes, no, I cannot do this. try to build it. Yeah, everything is fine. I think I need to restart my LSP. So analyzer logged and everything works fine. Okay, we did it. We find out how it works. So next, place the code that was in the curly brackets into a new file name front of the house as shown in listing 722. Yeah, we did it already. The compiler knows to look in this file because it came across the module declaration in the create root with the name front of house. Okay. Note that only need to load a file using mod and declaration once in your module tree. When the compiler knows the file is part of the project as known where in the module tree the code resides because of where you put the mod statement. Other files in your project should refer to the loaded file code using the path to where it was declared, as covered in the passes for referring to an item in the module tree. This is actually section 7.3. Okay, in other words, mod is not an include operation that you may have seen in other programming languages. Okay, so mod we should use keyword, not the mod one to include something. Sorry. And next we'll extract the hosting model to its own file. The process is a bit different because hosting is a child model of front of house, not of the root module. We'll place the file for hosting in a new directory that will be named for its as CentOS, the module tree. In this case, the front of house. To start moving hosting, we change the front of house RC to contain only the declaration of the module. Okay. So hosting directory and no, we need actually not hosting but front of house directory and hosting RC file, as I understand. Now we can grab this code. Let's place and format it. Yeah, all is good, I think. We still can do cargo build, cargo run, everything is fine. So submodule of front of house should be placed in directory with the same name front of house, and if it's hosting, we name the file hosting RC for the module hosting Some same process but in the subdirectory. Okay, this is good. So then we create directory and the file hosting RC to contain the definition made in the hosting module. Yeah, we did this. If we instead put hosting RC in the src directory, the compiler would expect the hosting RC code to be in a hosting module declared in the create root. Okay, yeah, this is clear. If we place the hosting, so we need to place it in src in this case. And not declared is child of the front of house module. The compiler rules for which files to check for which module's code means the directories and files more closely match the module tree. Okay. Alternate file paths. So there is some node section. So far, we've covered the most idiomatic file paths the Rust compiler uses, but Rust also supports an older style of file path for a module named front of house declared in the create root. The compiler will look for modules code in that we've covered and src front of house mod rc older style still supported path. So yeah, when we will work with some Rust code which not ours, and it's maybe it probably could be old code. I guess there should be some code like this because Rust state as a super stable language where you wrote something and it can live a long time then. So I believe there is a lot of useful old code, and these old styles we could met as well, so we can, but we don't need to use it. Okay. For a module named hosting that is a submodule front of house, the compiler will look for the module's code in src front of house hosting rc or same directory hosting and mod rc. If you use both styles for the same module, you'll get a compiler error. Okay. Using a mix of both styles for different modules in the same project is allowed, but might be confusing for people navigating your project. The main downside to the style that uses file name mod rc is that your project can end up with many files named mod rc, which can get confused when you have the open in your editor at the same time. Yeah, this is why I don't like the index.js or ts. You can have a lot of them. It just don't bring you value you don't know. It's just index, same name file. It don't give you a clue what it is. Okay. We've moved each module's code to a separate file and the module tree remained the same. The function call it at restaurant will work without any modification, even so the definitions live in different files. And this technique lets you move models to the new files as they grow in size. Note that the pub use create front of house hosting statement in srclib also hasn't changed, nor does use have any impact on what files are compiled as part of the crate. The mod keyword declares model and Rust look in the file with the same name as model for the code that goes into the module. Okay, so yeah, we did refactoring and moved some pieces to different files, but we left the code where we actually use the module unchanged. So summary of this chapter 7. Rust let you split a package into multiple crates and crate into modules, so you can refer to items defined in one module from another module. You can do this by specifying absolute or relative passes. These passes can be brought into scope with a use statement, so you can use a shorter pass for multiple uses of the item in that scope. Module code is private by default, but you can make definition public by adding the pub keyword. In the next chapter, we'll look at some collection data structures in the standard library that you can use in your neatly organized code. So yeah, we get the basics of the code organization of our project, and we can move forward to the common collections. So quickly look, this is the vector, string, hash map, etc. So yeah, we will jump onto it next time. Today that's it. Thank you for watching. We'll see you next time.